Shoots a 500-gram arrow at a 2-kilogram bird perched on a tall tree growing on flat, level ground. The arrow is launched from ground level with a speed of 40 meters per second at an angle of 30 degrees above the horizontal. It is traveling horizontally when it strikes and embeds in the bird. How far from the base of the tree do the bird and the arrow land? First, write the givens and the required. The mass of the arrow is 0.5 kilograms. The initial speed of the arrow is 40 meters per second at 30 degrees to the horizontal. The mass of the bird is 2 kilograms. The initial momentum of the bird is 0. The vertical momentum of the arrow after collision is also 0. We are looking at the distance traveled after the collision. What is the speed of the bird and the arrow after the collision? Due to the law of conservation of momentum, the total horizontal momentum is conserved. Momentum is equal to mass times speed. As this is an inelastic collision, the speed after the collision is the same for both the arrow and the bird. Solve for the horizontal speed of the bird and arrow after the collision. Sub in the known values and simplify. This gives you a speed of 6.93 meters per second forward. For how long do the bird and arrow fall after the collision? For this, we can look at the vertical impulse applied to the arrow by gravity. As it hits the bird, the vertical momentum is 0. Impulse is the change in momentum as well as F net times the change in time. In this case, the only force acting on the arrow is the force of gravity. Sub in the known values and solve for the change in time. Because the arrow travels in a parabolic path, the time it takes to reach the maximum height at the collision equals the time it takes to hit the ground after the collision. Therefore, the time it takes for the bird and the arrow to fall to the ground after collision is 2.04 seconds. How far did the bird and arrow travel? As the arrow falls, its horizontal speed stays the same because there are no horizontal forces acting on it. So, we can use the formula delta dx is equal to v prime x times delta t. Sub in known values, and this gives you a horizontal distance of 14.1 meters traveled. Therefore, the bird and the arrow fell 14 meters from the base of the tree.